Now Yee is going to demo the most awaited feature of Flyte, and that's signaling.
Hey, thank you. Hang on 1 second. Let me screen share. Cool. Everyone can see this?
Yep.
All right, let's start here. All right, so I'm here to talk very quickly about human-in-the-loop workflows with Flyte. This is a topic that we covered some time ago. I think Dan gave a pretty in-depth design and implementation discussion back late summer, early fall of last year. It has since been implemented and has been released in 1.3 of Flyte. So welcome you all to try it. Let us know how it goes and report back with any feature requests or issues that you might find. That said, quick agenda for today. We're going to just refresh for everyone what it is. We'll discuss the UX a little bit, remind everyone of the design and architecture, and then we'll jump into a quick couple of demos that hopefully highlights some of the things that people can now do with this new feature. So what is human in the loop? First off, human in the loop is just a human that can, a workflow where the outcome of the workflow and the course of the flow of the workflow is controlled by a person after the workflow starts. So typically, like, you only put in inputs at the very beginning. This will now allow a human to intercept something and either redirect the flow to different tasks or add inputs or approve an output of an earlier task. And this will also bring in the sleep functionality, which is not a human, but is related to the implementation. And why might you want to do this? Here are some classical examples of this guy. Labeling. So if you can think of like labeling cats and dogs, a deployment pipeline. So maybe this is not so much in the services sense, but maybe in like the modeling sense. You can think of human in the loop as a way to control and gate deployments of models and experiments. Supervised active learning, where a person has to go in and approve or annotate some outcome of some model running. Data curation, so gathering data, and canonical classic use cases that are like more business sense, like expense reports is a classic one, where there is an action that someone typically higher up will need to look at before the workflow can proceed. And the developer experience that we wanted to go for is the same as what we always strive for in Flyte and Flyte Kit. Code should be pretty Pythonic native. It should be easy to understand. It should leverage Flyte's existing type system. You should be able to compose it with all the existing Flyte Kit features and functionality, and it should be simple to interact with. And you can do so either from the UI or from the Flyte remote experience inside of Flyte Kit, or generic gRPC HTTP APIs if you so choose. And what does that look like? It comes in 3 different flavors. So the first flavor is waiting for user input. So you can imagine that a workflow proceeds, and then at some point it stops and it needs input from a human because it was not, for whatever reason, available at the beginning of the workflow execution. So this is how you would do it. You call in, wait for input, you give it a type, and then with this, the execution will pause with some timeout, waiting for someone to enter in what the input should be. So you get a little box like this, and we'll see this again momentarily when we do the demo. The second flavor is waiting for an approval. So this is basically like, if you look at this construct, we're just passing in the output of a prior task execution. Again, it has some timeout, after which, if not approved, it will fail. And you can approve it, you can disapprove it, or you can just support the workflow. And lastly is the aforementioned sleep. This will just basically do exactly what you expect. And this might be the example that we came up with was waiting for a pipeline just to as like a last step validation in a deployment pipeline. As a reminder, so this is roughly how it looks. The signals themselves, which all these three variants get turned into, are stored in a database. There is a new IDL service in Flyte IDL that is implemented by Flyte admin, and users will fulfill signals either through console or through gRPC REST to the signal service, and Flyte Propeller in its operation will periodically check for the fulfilled signal and then move on or time out the node. So the demo will look something like the following. So let's talk about the code first. So yeah, this is our example of a demo pipeline. Obviously, this has been simplified drastically to mock out any ML routines that might actually be present. So pretend that this function here will evaluate a model. The model is either pulled from a well-known location or you can pass it in as an argument. This function will basically take the model. Let's say you return some score, and then let's say you have another function that is capable of deploying the model to a certain percentage of your fleet. So you might construct a model deployment pipeline workflow that looks something like the following. So first, see if it's good, and you have a chance to approve whatever comes out of it, then deploy it to 10%, wait to see if that behaves as expected, deploy to say 50% of your fleet, and then just wait for an hour and then deploy to the rest of your pipeline. So at the end, if you do this, it'll look something like this, which I can probably zoom in there a little bit. But yeah, just straightforward linear pipeline. Let's relaunch this guy and we can see it in action. Probably should have done this earlier. This may, let's see how long this takes. This may take a second. While this is going, let's talk about this one. This is another workflow showing the wait for input style thing. So the example here is, for instance, if you were doing some labeling and you have a task that will generate, let's say, digits in the form of a NumPy array, and you can either choose to inspect those, whatever is generated by this, using the Flyte deck feature, which is included here, or you can interactively just pull the output of this task from like a Jupyter notebook, which we'll do in a second, and label it manually and then inject those scores or inject those label values back into the workflow. So in the interest of time, I will kick this one off as well for a relaunch. And then here, this should be now paused. So this was the first pause. This is just an approval node. You can either click on the little arrow here, or there is another arrow in the graph, and you can approve it. It also shows you the value that was popped in. At some point, this will now, so gate nodes, when they're running, are special in that they show paused. So that's like an alias for running, basically. And same thing again here. This shows this is the value that was passed into it. You can resume. It will structure it that way instead of the initial value, so that it would look like a completely linear thing and not depend back on the original score. And the last sleep takes an hour, so we'll not do that. But sometimes it's to say it will hang there for an hour or 58 minutes, I think, which is what it will set to, and then move on to the last step. So here, let's say you have a task. Let me make this a little bit bigger also. Let's say you have a task that produces some images. You can inspect them through, this is the canonical scikit learn data digits. I just pulled in a random set of 20 from somewhere in the middle of the range. And let's say you want to interact with this. How would you do that? I think that is key. So working again with Flyte Remote. Some code to this I didn't do. Some code to get the values from the prior task and please hold. Oh. Okay, so apparently I forgot to run through this again. So let's try that again. Hopefully this will go better this time. So again, this is just to show that you don't have to rely on the Flyte deck. The Flyte Remote object will be able to list signals. So currently here it only has one. If there are more, it will show them as a list, of course. In terms of labeling, rather than going through, we're just generating some random numbers and a random set that just coincides, and then you can send the labels that you hand annotated back through Flyte Remote into the running execution, and they will show up as inputs to the signal, which are then passed down to whatever has dependency on that node. So, and here, whatever was generated is now going to be, it should show up here as the outputs of this guy, and then let's say your whatever testing task will take that as an input. Yeah, I think that's it. Let us know if you try it out, run into any issues, and any other feedback that you might have. Thank you.
I have a good question.
Yeah.
So my name is Martin. I'm with Union. Yee, this is fantastic. So as this is a service and stored in a database, I assume that somebody could actually do a report and use logging and see what approvals were in the past and so on.
I believe so, yes.
Okay, so that would be a very valuable feature, because specifically in labeling, if you go through and you run through, not approval, but actually if you do an approval and that is potentially the wrong approval, and somebody has to go back and double check, that would be good to have this logged. And obviously if there's a ability to do so, that would be fantastic.
Yeah, I think it will probably, I think we will probably add an API on top of that, just to discourage raw querying of the database, but yeah, it is persisted. So the data is certainly there and it is possible to get back.
Okay, great, thanks.
Stop sharing.
Any more questions?
So I just wanted to say this is super awesome. So basically with what you showed, you could theoretically iterate through a batch, in batches, iterate through entire data set and label it purely using Flyte, and then some UI that has access to enough data for a human to be able to say what the label is.
Yeah, for sure. It is possible. I'm gonna let Keithan take this one actually, but it's the Flyte console itself may not be it depends on the size of what you're doing, but if you imagine a team of 100 people working to label 100,000 things, that's probably not the best thing to use. But it's certainly possible to use this for smaller data sets.
Well, active learning is the perfect use case, because the whole point of it is the model picks some handful of data points, and it's hard, right along the decision boundary for the human to disambiguate. So yeah, I can see some kind of high script hacking going on here. in a flight deck itself so that you can send, you can do the gRPC call directly in a flight deck. Not suggesting we do that, but in theory that is possible.
And I think for more serious workflow use cases, like when you do like you said it, large scale labeling, then I think it's probably you need an interface to do that. But I think this is well prepared to surface such an interface down the road as well. So I think I just want to say this is fantastic. Also in the context of as we have seen, what happened with ChatGPT and models that have been trained in a very interactive way. I think this is a massive step forward for us, and I think there's a lot that I can see from the community coming back to exploring this functionality. So I just want to say to the team who has developed this, Dan and Yee and so on, and whoever else was involved, this is fantastic. Thank you very much. Super exciting.
Yeah,
Okay,
I can go in. Yeah, I just the goal of, and I think my name's Ketan. I mostly do nothing much. I just be part of the community at the moment. But what when we started this project and we were discussing, what we wanted was it to be the canonical infrastructure piece that you don't have to rebuild again and again, right? Like this. That was the goal of doing this. And when we did it, you were like, okay, for many basic use cases, you should not also have to rebuild the UI. That's what the goal was. And so Flyte Console is a simple UI that many companies already run. And they should be able to use a simplified interface to approve, right? Which is like just a click of a button. It's not even data. But in case of having data that you wanted to label, we realize it's very complicated. And that's why Yee and I yesterday kind of wanted to do a Jupyter Notebook demo to show that in the absence of a fancy UI, you could use Jupyter Notebook to essentially fetch the data, and probably we could write a simplified part within the FlightKit SDK or an extension on FlightKit SDK that could allow you to do that better in Jupyter Notebooks. But this doesn't, again, Flyte is never not competing with the labeling systems and so on. It's just enabling a more end-to-end flow for people who are trying to label as well as train, as well as, and we learned this by working with a lot of companies that deal with massive amounts of data, like mapping data, LiDAR data, 3D data, as well as like genomics, etc. And they all wanted to do such a thing in a simplistic way. And so there it is available. Please use it. I think it is still early. We are going to find some potential issues in the API surface, etc. Definitely surface them. But we've been using it. It feels amazing to use it. It's like it's interactive now. That's amazing. Thank you, Yee.
Awesome. Love this feature. To reiterate what Yee said, signaling can be pretty useful in cases where human intervention is required. If you'd like a deeper dive into what signaling is and the preliminary details, please check out the preceding presentation by Dan that was given a few months ago. You can find the video on YouTube channel.